Hey, this is a 6.1 second video. In our last video we just looked at the fact that the quadratic equation is simply a matter of taking the quadratic function and setting it to 0. And when y equals 0, what does x equal? That's what the quadratic equation is all about. And the next item on 6.1 is this notion of the zero factor property. The zero factor property is really simple to understand. See if you can calculate this. What is the answer to this? Well, the answer is 0, because we're multiplying by 0. Okay, smarty pants, let's try this. Well, the answer again is 0, because anytime you multiply something by 0, you get 0, and 0 equals 0. So what does that tell you? That tells you that if you can figure out the factors of an equation and figure out how part of it will be 0, you will get yourself the answer. Here's a case in point. X squared minus x minus 6 equals 0. So if we take this equation, this is a quadratic equation, it's set equal to 0. If I factor this side, I can factor it using my reverse FOIL. I know that the values here will multiply to 6 and they will add to -1. So I know that 2 times 3 adds up to 6, so I'm going to have a 3 and a 2. And we know that it's a negative x, so it's a minus 3 and plus 2. So there we go. So we remember from up here that anything times 0 equals 0. So when I solve for x here, I'm going to have two solutions. And I'm going to call them the pink and the blue. And in the pink solution, what x would I need to make this a 0? Because if I can make this a 0, that'll be 0 times whatever equals 0. So in order to make this a 0, x would have to equal 3. So if I say x minus 3 equals 0, x equals 3. That's my pink solution. And that is one of the roots of the equation. Over on this side, what would x have to equal in order to get this thing to equal 0? We'll call that the blue solution. Well, x plus 2 equals 0. Therefore, x equals -2. And that's the blue solution. So those are my two solutions. And if I were to graph this, 1, 2, 3, 4, 5, 1, 2, 3, 4. I know that x equals 3 and x equals -2 would be on the parabola.